Hello and welcome to this film about periodic trends, which may well be the first film you're watching about new material in year 12. It describes some of the basics about the patterns that we observe in the periodic table, and hopefully by the end of this film, which is quite a short film because we don't really go into explaining the patterns, we just try and understand what they are. We look at things like electronegativity, atomic radius, and ionisation energy for atoms, whether that's the first ionisation energy or whether it's successive ionisation energies like the second or the third and so on. Okay, so we'll start off just by looking at atomic radius. This one is fairly self-explanatory, I suppose, and quite a simple idea. If you imagine, as we have in these three diagrams, this being a magnesium atom and this one being a sodium atom as it happens, but it doesn't really matter what they are. Potassium there. Okay, really and truly, if you're imagining the atom as a spherical object with a centre and an outside, then the radius is quite simply the distance from the centre to the outside. So the atomic radius is a measure of the size of an atom, or the distance from the centre of the nucleus to the outside of the outer shell. Quite simple. Electronegativity, a long word for not a particularly difficult concept. It's an important definition to understand because then you can understand better why some atoms don't have electronegativity values. Electronegativity is a measure of the strength of attraction between an atom and the electrons in a covalent bond that involve that atom. Okay, now why does it not apply to all atoms? Well, in particular, you've got the noble gases here, right? Noble gases often don't get given electronegativity values because they don't tend to form bonds with other atoms. As you know, they're quite unreactive things. So if you can't make them bond with other atoms, you can't measure how strongly they attract the electrons in a covalent bond. So that's what electronegativity is. It's a measure of the strength of an attraction between an atom and any electrons that it's sharing with another atom in a covalent bond. And finally, looking at ionisation energy, which may be a first ionisation energy or successive ionisation energies, as I've said, second and third and fourth, and however many electrons you've got in an atom, you can remove them all if you want, if you've got enough energy to supply. First of all, here's the definition of what an ionisation energy is. Okay, so that's an important definition just simply to learn, okay, because if you can't define it, you won't be able to write equations later. So it's the energy required to remove 1 mole of electrons from 1 mole of gaseous atoms. So that's separate atoms, not molecules, and not solid, but they've got to be a gas. So taking electrons away from these and forming 1 mole of gaseous 1+ ions. Okay, and if you know that definition, then you can use it to write equations. So for example, if I wanted to write the first ionisation energy for magnesium, well, if we took an electron away from a magnesium atom in the gaseous state, okay, we'd turn it into a magnesium ion in the gaseous state. What charge would it have? Well, we've only removed 1 electron because it's the first ionisation energy, and we'd have an electron left over. Okay, if we did the second ionisation energy of magnesium, this is now removing a second electron, so we must be starting from a positive ion, and that would be turning magnesium ions, 1+ ions, into magnesium 2+ ions, and again we're releasing an electron, and you could do this as many times as you had electrons, but just simply to illustrate a third ionisation energy of magnesium, we're now taking a third electron away, so we've already taken 2 away, so we've got 2+ ion, and we're turning it into Mg3+, which would also be gaseous, according to the definition of what we're measuring here, and an electron is released. Okay, so that is what we mean by these 3 key ideas, which we observe trends in the periodic table of. So next film to watch is the periodic trends 2. And it explains why we see the trends that we see in the periodic table.